Welcome everyone to the panel discussion on Internet of Things in ICC 2016. My name is Soumya Datta. I'm the moderator and as well as a panelist in this panel. This is actually organized from the IEEE Society Future Directions, so which Tom Coughlin chairs, and you can see on the screen a couple of objectives in this future directions. One of the main aspect of this is create new initiatives on the important topics on consumer electronics and IoT primarily being consumer technology, so we felt always the need of pushing Internet of Things through as a part of the objectives. And this is just a highlight of what we have been doing in the C Society Future Directions on IoT. So as of the past activities, you can see we have done a lot of panel discussions. Last year, organized several special sessions on IoT, also organized workshops. And out of all these activities, we generated a lot of articles that has already been published in the C magazine, and several of them are actually in the process of being published. And as of upcoming activities, so this is a part of the, this is the first activity in 2016, and we hope to continue the activities and follow up with more panel discussions, special sessions, and workshops. With that, I'd just like to highlight some of the discussions that we have within the group of, within the IoT team. So we, over emails or informal discussions has already centered around some of the fundamental issues of IoT. For example, whether IoT is a marketing term or is it a general term, what actually IoT means, how consumer comes to the term of the critical issues of privacy and trust. Then standards in IoT, are there like too much of them or do we need a consolidation? Then big data approach, interoperability issues, healthcare altogether. So let me introduce the panelists. I'm very honored to actually have three eminent persons. Bob Frankston, he's IEEE and ACM fellow, and he would be talking a lot about the things and Internet of Things, API first approach, etc. Then Nahum Gershon, he's principal scientist in the MITRE Corporation, and he'll be talking about wearables, humans, and things as a part of one ecosystem. And then it would be followed by Lee Stogner. He's associated with IEEE for a long time, and he's a senior member, and he'll be talking about smart grid and Internet of Things. And finally, I will conclude the presentation with a brief introduction on what we call as mobile edge computing or fog computing, and how does it relate with Internet of Things. And finally, we'll have discussion with audience. I'm hoping by that time we'll have more audience to discuss with. So with that, I invite Bob to begin.
Have my last word? Plug this in. Well, just put it down.
Yeah.
Okay, plug in a connector. We bow down before our device and perform the rituals. Extend. Snow. Snow.
If you duplicate that.
Yeah, no, not duplicate, extend.
Extend. Okay.
Yes. We'll have a separate session on tutorial on PowerPoint.
Last year.
So if we do F5, we see a show. Okay. I renamed it Things and the Internet. I spoke a little about infrastructure this morning because you were all here. I don't have to repeat it. Actually, many of you were. Okay. Really, it's connected. What's new is you have things that are connected and have local programming. The problem is we can't get to them. They can't connect to each other. But let's move on. I just got it from this session. So if we really talk about the Internet of Things and empowerment, we have one view of Internet of Things that are just viewed in terms of apps. people create one solution and ship it. But for me, the Internet of Things is really about openness and discovering what we can do with connected devices. So this example is built on the APIs. It controls the device on the left, but I can now add value. I can now connect things. And this is really when we talk about an Internet of Things, this is what I think about. It's the connections, not just what the apps, contained with, not just device contained within apps. So I use the term API first. Think about the interfaces between devices, then anyone can build apps. Of course, the people making devices are going to want to do their own applications, but the real value of internetwork things is the ability to do more than it was built in. And this is an example of what I can do with APIs. I can, do my own application, for example, that gets route information from a car instead of just using it for one diagnostic purpose. So this is my reality check. I showed this morning. This is something I put together, and this is the entire internet as far as I'm concerned. These devices speak to each other locally, and I've got a browser running the phone, uses standard internet protocols connecting to the device. Now, this morning, This morning, I basically went on to talk about very general policy issues. Here, my emphasis is, basically, if you heard Peter Hotty's talk about JavaScript and new applications, point is, this is accessible, and we're in a phase now, like early PCs, where we should be exploring what we could do, not just settling for solutions. Matter of fact, if you notice that orange stand, that was 3D printed. There's a lot of experimenting and learning at this stage. So question is, what is the Internet of Things? Is it a butterfly? Is it an axe murder? I don't know. Sorry, Rorschach joke. So typically it's viewed as an extension of existing business models. The original term came for radio frequency ID seeing things. People want to monetize your light switch. I want to bring all the data back to a central cloud server, whose name might be Watson. And the other view is sort of home automation. You have these protocols for a particular application, which, the narrative is, it's the home automation Jetsons model of the world. But these are all, sort of nibbling at the edge, or given the possibilities of ways people view it. The problem I have with smart cities is I want to see that empowers me, not just sort of engineer for a purpose. And in fact, a lot of what's called Internet of Things is embedded system engineering with something like Wi-Fi added in. And we also have sensors and edge networks. But again, that's viewing from the center. From the edge, it's just that what I showed you. The whole Internet is that device in my house. So it's things simply connecting. And what it enables is a combination of do-it-yourself. You can create your own solutions using these devices, or you can work with others. It doesn't have to be a cloud computer, it just could be you and your friends. But what's important is to have APIs, and it's actually almost the 20th anniversary, the first time I said this in ICCE in Singapore. I'm waiting. But the reason I mentioned Smart Device Link is I'm looking for hopeful trends, like automobiles are plugged into ecosystems, like Apple's ecosystem or Android's. I need to learn more about Smart Device Link, which apparently is an open protocol. And as I walk around the floor, I'm seeing more interest in open protocols. So this is a very good start for the Internet of Things that enables us to explore. In this session, I'm going to geek out. I'm going to talk about details and give you a sense of what it's like to program these things. And in fact, I'm using Windows on devices now just to get the simple development tools. I'm not really tied to that platform, but it enables me to do rapid development. Matter of fact, and language I use is TypeScript. Again, for Peter Hotty's talk, you saw the mention of TypeScript. And it basically makes it easy to program. So you can see the IDE screen here giving me hints. So I'm just, again, giving you a sense of sort of very pragmatic and encourage you to explore. This is a complete web server. Now I can make it fancier, but that line is a complete web server. That's all I need to do a web server. I don't even need the HTTP. A few more lines of code, I can rebuild it all. So the other lesson is, when you read about the cloud, the web, it sounds very big, very complex, very inaccessible. This is accessible. This is the web. It's the web you can make yourself. And it's also very simple to deal with hardware. Because of the architecture, there's a huge amount of complexity in these chips, but at this point, we can use that complexity to make it simple to build applications. And that's really, again, IoT is, instead of you have to spend years writing circuits, learning what a soldering iron is, burning yourself, just write a few lines of code, and you get a huge amount of leverage. So just to know the details, on the client side, basically there's no web server, so I put it all together. I send client-side code, because if you notice in that picture that both sides are running code. And there's no, again, you can roll everything yourself from scratch, doing peer connectivity, and it's very simple. So again, lunch talk yesterday, you saw what you can do when you get messages from devices. We're learning how to hook things up. That HTML5 engine limit, I've discovered one less limit yesterday. And the other thing, how many of you know what JSON is? Okay. I mean, basically it's a JavaScript structure notation. So you use the same notation to exchange messages as the code. So it all comes together very nicely. So basically what you do is you basically take a Java object, just say stringify, send it to your server, and parse it. And that's all it takes to exchange messages. You don't have to set up any complex relationship. If you want to check for errors, you can use TypeScript. You don't have to. It's just very simple. And, you know, I'm also playing with certificates, authorization, because encryption is very important. But the key thing is that it's all very simple and accessible. Now, I do need to make sure, you know, the current internet has its problems. My device inside my house is not directly accessible. But my goal is to be future-looking and understand the architecture. So any change I make to solve a problem, in other words, I program as if I'm directly connected. Across the architectural line, I might have to hook up the outside internet to my inside internet. But if that goes away, my code doesn't change if I fix the problem. So what have I learned? You learned you don't hit the backspace, you don't hit the space bar too hard because you give away the show. So the goal is to remove the mystery. You don't need big servers. It's to remind people that local connectivity is very important, maintain the architectural vision, which allows me to basically solve problems separately without having to resolve it each time. So this I gave this morning. We communicate by exchanging packets, and this is why we don't need a separate solution for each device. We have generic connectivity. We just send packets. Okay. Again, since I said this morning, I'm going to go through this quickly, but basically, in this example, I show we're exchanging images, but that could be any IoT device exchanging messages between the devices. They see each other directly. They don't know there's anything on the other side of that red boundary. They just throw packets somewhere and they arrive. They just focus on the exchanges between the two endpoints. So in theory, I can take one device, I have a little you know in my bag, take it anywhere in the world and it still works. And at the end, I can show you my connection to my house, which works in my house or works here. So I won't go through. So what things need is the ability to focus on relationships, just the two devices. We need application protocols, not network protocols, but application protocols that make it easy. Part of this is JSON, part of this is how do you find devices. But the other thing we need is a free-to-use infrastructure. We need to pay people to maintain the wires and the facilities, but the design restriction is that the devices cannot be required to negotiate. The failure mode should not be, if you can't pay for the wire, your application is not valuable enough, today you can't do it. You stopped. at the edge of a network. But devices to be portable and work everywhere need a free-to-use infrastructure. And we have examples. Route 1 is free to use. Our GPS directions are free to use. When you get a direction on your device, you don't have to pay anybody for that route. The route is free. You have to pay for the roads, but those roads are paid for by the community because they can't tax you for using the route. Route 1 doesn't exist except as signs posted up somewhere. The roads aren't called Route 1. The roads are called whatever the local street is, except if somebody's too lazy these days. But in general, Route 1 is just a set of signs. So we pay for infrastructure by paying for roads, but we use it as routes. And thus the routes are free to use. We can do this now with open Wi-Fi, and in the future we'll have better protocols. And we have APIs like GPS and other APIs. Okay. So now there are a lot of challenges. This is about sort of encouraging people to play. We have challenges such as distributed trust. What's the mechanism? Who's allowed to use it? Who's allowed to turn on your light? Do they have to be in the house? Those are all issues which we have to rethink because we're used to basically, if you're here, you have access. Now everything's connected. How do we rethink that? The cloud, what should run locally? What depends on something remote? What happens if the connection goes down? So this is the start of a longer discussion, but since it's a panel, I just wanted to, begin the conversation. So I'd say any questions, but let's save them, I presume, for the end.
Thanks. Thanks, Bob. So our next panelist is Nahum. You can start.
Yeah, okay. You see this watch? Very expensive, okay? I bought it in order to use it as a tracker, okay? So I walk, and the number of steps does not change continuously, like I used to with other trackers. It stands still for a few minutes, and then it jumps by 300 steps. The same thing happens with the phone. The phone has a tracker, the same thing. I walk, and with the phone, even when I climb stairs, I can climb 5 flights of stairs, it says 0. After 1 or 2 minutes, it says 1. And then a little bit more, maybe 2 or 3, 4, and sometimes 5, okay? So it turns out that the people who designed it actually don't understand how human beings like to have things. We like to have instant gratification. When we walk, we put an effort, we would like something to acknowledge it, okay? So that's just like one problem with what we call Internet of Things, that many people who design things don't have a clue how human beings actually like to have things, how they do things, okay? I'm not saying the people who design the watch, there are some nice things about the watch, but those people who designed the fitness app did not actually do the homework right. And that's actually a point that engineers who design things that relate to human beings need to understand how human beings do things. And in order to understand them, maybe they need to collaborate with people who do, like health professionals, psychologists, social scientists. And the same thing actually goes to many other areas. Okay, for example, where do you put the fitness device? Do you put it on your arm or you put it on your core? There are some rumors if you put it on the core, it's more accurate. But they don't give you the same numbers. And I made experiments. I had a number of tracking devices. Right now on me, I have a Fitbit in my pocket. I have an iPhone. I have the watch here. And I have another Fitbit device because I'm experimenting, sometimes with 2 devices of the same type. And I walked 100 steps in around the track. And I compared, and not all the numbers are the same. Some of them were similar, like within 1 or 2%, and one of them in particular was like 30 or 40% difference, okay? And the question is accuracy necessary? What is the function of fitness devices? Is it to tell you that you walked 9,000 steps, or actually or just to make you active, okay? how do you measure flights of stairs? You know, the Fitbit and other ones give you flights of stairs. Another one that I had, tracker, gives you a number of feet. So when I wake up in the morning, from my bed, I go to the bathroom on a flat surface. When I come back, I have 8 feet. Why? Not every day the same. Then I climb up and down the stairs. Sometimes I get 8 feet, sometimes I get 12 feet. It differs. I took those two devices and the same type in the same pocket, walked for half a mile on a track, totally flat surface. One of them gave me change of height of feet, 12 feet, and the other gave me 105. Okay, and in addition, you know, for us, the number of feet climbed does not mean much. It has to have a function of time, because if you walk very slowly, you don't exercise your heart, right? But you still climb, right? Very slowly. But there is a function. You need to have flights of stairs so the time factor goes in, okay? And you know, I can go on and on with all kinds of examples, heart rate, and you know, in fact, I go on a bus, let's say from New York to Washington, D.C., where I live. Sometimes, depending on the driver, if the bus drives like this and there are bumps on the road. So one time, I sat for 4 hours. I sat going to the men's room once or twice in the bus. He told me that I climbed 39 flights of stairs. Okay. And they should think about maybe have a switch of on and off. So there's lots of problems with this. I know we talk here a lot about the future, but there are lots of problems about the present. So device designers don't know sometimes what they are doing. Okay, wearable things. Okay, you know, some devices I perceive them as part of my body. If you implant something here, it's part of my body. So the interaction or the way I relate to that is like it's part of my body. Even my phone is sometimes part of my body. I relate to it, okay? And the whole notion of human-computer interaction, you sit and there is a computer and you interact, does not apply here. And the trouble of using an area like human-computer interaction, using the same old metaphor, it actually clouds and limits the thinking of the innovative directions that otherwise those minds had to work with. And the same thing, I congratulate the Consumer Electronics Association for changing the name to Consumer Technology Association. It's a very good change because we don't need any more with vacuum tubes, okay? So it's technology, not so much electronics, okay? So, and wearables, when you deal with wearables and with things, you have to think about the humans and how they all come to one ecosystem. So it's not just things, it's also humans in the loop. And for example, with my phone, as I said, it's a wearable. It's a first of all, command and control. A phone, yeah, we forgot. A phone used to be used for phone conversations, but it's also a command and control center with all the apps you control different things in your house, for example. Yeah, but it's also a wearable, okay? And for example, when I walk out of my house, the devices in my house know that my phone left the range of the Wi-Fi, and then lights are dimmed, and maybe they turn on and off the radio, the camera goes on, and so on. And when I come home, it's the other way around. So it's you know, and all those devices could also interact, you know, independently of humans. You know that the complexity theory about how insects interact with each other, and you have a swarm of insects that seems to know what they're doing. And the same thing will happen with devices, and maybe sometimes with humans too, okay? There are safety issues, okay? You know, for example, this device is made of aluminum, and I'm a chemist. Aluminum is known to have potential effects on, not nice potential effects on humans. I don't want to wake up in 20 years after wearing this device and get the message, oh, you got sick because this, okay? I sent to the manufacturers, that goes unmentioned, you can just guess who it is. I sent them a question, have you tested how much of aluminum goes into my body when I wear it or not? They have not responded to me, okay? I'm going to tweet it, okay? And maybe then they will answer me. So there is, and there are some parts of the IEEE that actually start to deal with the safety aspects of wearables and IoT, and of course also cell phones that you have on you. They have radiation, and just it brings me just the same thing that you have to to have people, not just technologists, but also people who understand the subject matter, for example, goes into cities, for example. How many of you heard about Jane Jacobs? Okay. She lived in the 60s, 56 in New York. She was not educated, but she really understood from observation how cities work. And at that time, there was a dogma among the urban designers to destroy the old cities, build highways and tall buildings with park around them. She said it will not work. And everybody said she's wrong, she's wrong, she's wrong, she's not what she's talking. Guess what? She was right. So when you deal with any system, whether the wearables, whether tracking devices, smart cities, smart grids, you need to understand the subject matter before you actually try to build technologies that might change it to a way that people would not like to see it. And there are also health, the health considerations. Now with all the devices, we can also measure how state, and there are many, many questions. For example, what do we do with all the data? What happens if I'm a hypochondriac, okay? We are going to actually to have a workshop on the quantified human in Florida in August. And if you ask me, I can give you the potential link for that. So, any comments, questions quickly before they move me out of the stage?
Just one quick comment is, I often cite Jane Jacobs versus Robert Moses. And, people want to plan all these things, but Jane Jacobs shows is how sort of a rich, chaotic environment can produce very good results. I think the internet is also that dynamic.
Yeah, it was in one way chaotic, one way it was also ordered. I can discuss with you later on.
Yes.
There was also an order thing there.
Yes.
We can discuss it later on.
Yes.
Okay, thank you.
Thank you very much, Nahom. So next in line, we have the presentation from Lee.
I appreciate we're the last presenters before the big event tonight, so hopefully we'll all be on time. The IEEE is a fascinating place. It allows us to do a lot of things that would be virtually impossible in other organizations or in just average personal life. Two things that I've had the honor and pleasure of being a part of is the IEEE effort on the smart grid and its complementary effort called the Internet of Things. Quickly, the IEEE, as you know, we're big, we're around the world, and that we're doing things called initiatives, both internal to consumer electronics and also across the IEEE to make sure we're planting the right seeds for tomorrow. We call them initiatives. Two of the most important ones are the Smart Grid and the IEEE Internet of Things initiative. A quick definition. Smart Grid is an update to the existing worldwide electric grid. In many places, it's 100 years old. In most places, it has not truly communicated around and through its network such that the controllers back somewhere at headquarters knew truly what was happening and what is trending to a happening. So through the smart grid, it's an update in both communications and responsive technology that allows energy to be managed better, to make it more reliable, more able to bounce back into operation, and also more resistant to things that happen. We've just seen a report where terrorists took down the grid in the Ukraine. We can't afford that to happen here in the U.S., and there have been several attempts to bring down the grid in the U.S. as well. So the smart grid will give us a lot of abilities to make ourselves more efficient in transferring power and managing the network to make sure the power grid stays up. In parallel, Similar technology has been building the Internet of Things, that real-time, very redundant, very fault-tolerant way of transferring information from me to you. It's not on a direct wire. There are nodes, there are servers, there's routers, there's redundant networks. It is designed to stay up. And the technology of the Internet of Things has been constantly being shared with the smart grid designers such that they share common technology, as well as they share networks to make sure that the flow of information for you and I to watch Netflix is also similar to the flow of information to keep the smart grid delivering power. Boom. In 60 seconds, I like this slide. It shows all the things that are being worked around the world through the Internet of Things. And somewhere through all this, you've got critical information being transferred from power grid to power grid and device and asset all across the smart grid. They're not, you can't separate them. They're merged at multiple hips, if you will. The smart grid is not a brand new wire you see going between the telephone poles up and down the highway. It makes use of the internet wires. It makes use of M2M connections through our telecom. It all works together. I just hope it stays up. Okay, what can the smart grid and IoT do together? Well, at its base, communications. What is happening in terms of one part of the grid versus another part of the grid? That information has to flow, or any of the other applications simply won't be reliable and won't work at its peak efficiency. Real-time monitoring and control. Before the Internet of Things, what do the power companies have? Well, they had the telephone. I'll call plant number 74 or substation 16 and see what's happening. And that becomes really critical if a snowstorm or ice storm or some other disturbance flows around the territory of the utility. With monitoring and control, you know what's happening. And that becomes very important to make sure that the various breakers, substations, and other assets of the smart grid are properly being utilized here and wherever that need happens. Asset management. Let's try to think of a utility as a plant that you would see on the interstate. Most plants average 200 to 400 and some are even 1 million square feet. For them to manufacture products and ship to the customers, plant managers, supervisors, engineers have to know the state of the production equipment and the supporting systems such as utilities and other things scattered throughout the plant. Well, a modern day power company is also a plant, if you will. Instead of being 400,000 square feet, it could be 10,000 square miles. What happens when the plant has a problem? Well, in the past, all the power company, because they're not connected to their assets in real time, would simply say, well, Lee, your power will be back up somewhere between 48 and 72 hours. In a manufacturing plant, if a production engineer told that to the plant manager that, I don't know when it's going to be up, but it'll be up sometime this week, they'd probably be gone at the end of the day. So with all this constant real-time communications, we are plugged into the assets of the manufacturing plant with IoT and very well plugged into the assets of a power company. For example, what can you do with it? Well, in modern day operations, there's the idea of predictive and proactive maintenance. In other words, collect information from the circuit breaker, the substation, and all those other boxes you see up and down the highway between generation, transmission, and customer that can feed back information about how that piece of asset is trending with trending analysis, the power company can know what circuit breaker might have a problem, in many ways even weeks before total failure. And with that information, they can answer the question, how long before something is brought back up, or how long before something might fail. Data analytics. Petabytes of information is flowing from the smart meter that is on the side of your house, and also the smart monitor at the substation, such that big data models can be generated to understand what is happening to the total utility grid because of things such as weather, the difference between day and night, and the heat and cold associated with that, the usage of the grid, big time data analysis, data modeling, even AI is being brought to bear to understand the power grid, how it's operating, how it's not operating, and it won't happen and it can't grow to be even better without this very much integrated world of smart grid and IoT. You got to know the names of the players if you're going to be in this business. What you see here is a slide that shows the typical companies and experts that have been involved heavily in the rebuild and upgrade of the grid to something called smart. You'll see new players, you'll see old players, but one key thing is you'll see a lot of players on this slide that 10 years ago may have been associated with the utility in the front office for processing billing and things like that. Now they're in touch with and integrated with the devices right down to the ground level to make sure that the grid, I'll say it again, is reliable and it has as close to 100% uptime as possible. So some of these companies, no, I'll change that. A lot of these companies did not exist even 5 years ago. They're brand new. They brought new ideas, new technology to the business. So this is a place in industry to invest your own smarts and your next idea. So we're going to go from the smart grid landscape to the IoT landscape. A lot of these companies didn't exist even 2 years ago, and they're bringing forth to the world of connected devices that range from Mr. Gershon's wearables to that circuit breaker somewhere out there on the highway that is critical to the operation of a hospital a little further down the transmission line. Again, this marketplace is growing very fast. If you're an entrepreneur, now's the time to get into smart grid or IoT. The market is big enough to support you and my idea. Okay, for all these things to work together, you need standards. The IEEE is pretty good at creating standards that fit devices from Taiwan to Seattle to London and so forth. You'll see some numbers of standards on this slide, such as IEEE 1675, the much bigger and complex IEEE 2030. These standards make it possible to interconnect the hardware, understand the flow of energy, and make sure it works reliably. So other things do plug in to the smart grid, such as electric vehicles and manufacturing plants, and we're organizing them together as to a major smart grid for the utility, and then we're also slicing and dicing this grid into things called microgrids, which could be a city, it could be a campus, it could be an entity with just a couple of buildings. So the microgrid plugs into the smart grid, and the smart grid plugs into the Internet of Things. Another slice of the same information is the smart grid and transportation standards. It all works together. You need all sorts of things moved here and there to make sure that the smart grid is being maintained. And that brings another buzzword out, which is called fleet management. All this information being collected from the electrical assets is also including the information being collected from trucks and specialized equipment that are on wheels that must be in the right place at the right time to assist and maintain the grid. How is it connected? IoT. Smart building standards. Here's where the microgrids come to bear. Buildings are complex these days with all sorts of internal services for HVAC, energy management, security. All these things have to interconnect, and you see some of the IEEE standards that maintains not only the connectivity, but the overall optimization and use of these items. IoT communication standards by themselves, yes, IEEE very heavily involved in this, not only at the IEEE level, but at the world level. Without IEEE communication standards, none of the assets and systems you see on the slide could operate without the standards. So, if you want to learn more, we've got several places that were designed to really become a focus not only for the smart grid, and here you see the smart grid portal, but also Internet of Things. So this address is easy to remember, smartgrid.ieee.org. We try to make this as efficient a visit as we can, and it's organized, here it comes, a whole lot better than the IEEE.org. The IoT web portal, every day it gathers more information about things that have been done, will be done, and otherwise keeps all of this connected together. For more information, here's the table, IEEE, the Smart Grid Initiative, the Internet of Things Initiative, the Smart Grid, on LinkedIn where we do a lot of discussion, IEEE Internet of Things, on LinkedIn, standards, there's tens of thousands of standards that interact together to make this work, and I should have said thousands. There are tens of thousands of IP items in the Explorer library that keeps both these systems interconnected and running well. We've got other things such as Twitter, we've got Flipboard, we've got a variety of ways to get to people information at the way they want to consume, whether it's at a newsletter, a magazine, a journal, or something electronic that's updated frequently so you can know the latest news that might spark your interest, and then you go do a deep dive in technology to keep up. So with that, I'll turn things back over to Soumya.
Thank you very much, Lee. And so,
I've got the question.
no, it's one more left.
It's you?
Yeah.
Okay, a friend of mine, Sanch Tripal, said,
Wait.
adding sensors, what?
I go after.
Oh, okay.
Then there is
He's
a
the
question.
person too.
Yeah. So the three panelists presented three different views into different domains in IoT, and continuing in that tradition, I took another aspect, which is mobile edge computing. Relates a little bit to the discussion started by Bob about local data processing, whether it should be done locally or in the cloud. So if you look into the current trend of Internet of Things, data analysis, data aggregation, so it basically looks like this. So whatever sensors you might have, be it the sensors in the vehicles, be it wearable sensors, which Nahum was talking about, the idea is to transport everything to a smartphone and then utilize the wireless technologies like 3G or Wi-Fi and get them into a central point of aggregation and analysis, which is the cloud. So, but at the same time, over the last couple of years, we have started witnessing a shift in the paradigm. New computing platform came into being, which we are calling as edge computing, and we have started seeing a massive change in the trend from cloud to the edge. Here, I mean, an obvious question comes into the picture, which is that why we are witnessing this paradigm shift. So to answer that, we need to consider several aspects. For example, if you just look at a very general architecture of the overall IoT ecosystem, you'll see that there is an explosion of the things or the connected objects at the edge of the network. So if you believe the numbers put forward by Cisco, Ericsson, so you know that there would be 30 to 50 billion of connected things by 2020. And all these things are actually situated at the edge of the network. So, and if you take a closer look into all these things, you'll notice several things. For example, there are many powerful devices as well as there are constrained devices. These are these devices are highly distributed and quite dense, and majority of them are actually mobile. And at the same time, some of the consumer applications that need real-time operation with very low latency and high quality of service. For example, if you are talking about the use case of highly autonomous and interactive driving. So all these actually make us consider about the fact that if we can push the infrastructure, the capabilities of cloud towards the edge of the network, that would give rise to the mobile edge computing platform. So just to discuss some characteristics and benefits. MEC or mobile edge computing. So this platform comes with several distinct characteristics. The first thing is, since it's situated at the edge of the network, the first characteristics is its proximity to the end users, as well as it's quite dense. It has a very dense geographic distribution, and it provides open platform and supports high mobility. And from the industrial side, the value addition that it brings to the entire ecosystem is that provides consumer-centric services with reduced latency and the improved quality of service. So the picture that you see, it's actually from Ericsson. So they are actually right in saying that the intelligence is actually moving towards the edge, and it basically brings the discussion to what Bob was saying. So we should give more importance on local data processing. There are many benefits of mobile edge computing. So it's the first one is since we can operate from the edge. For example, we can deploy a certain one of these platforms into devices like access points, set-top boxes, M2M gateways, even in roadside units if you are in the connected vehicle domain. And operating from the edge results in superior user experience, real-time data analysis and actuation, reduced latency that I have already talked about. A very distinct aspect of this is it saves a lot of bandwidth because the data processing takes place at the edge of the network. And another very important aspect of this is promotes a distributed architecture. And due to that fact, MEC promotes fault tolerance. So even if one MEC node goes down, you have several others that could actually potentially replace it and that are in the vicinity. So it promotes reliability and maintains scalability of the overall system. And just to give you an example how MEC platform and IoT could interoperate. So if you see the data coming from all these different domains like vehicles, smartphones, or connected gaming, or even fleet management that Lee was pointing about. So all the data could be collected through the wireless channels into a MEC server, which is actually sitting in between the, sitting at the edge, and then we have the core and the internet. And all the functionalities of cloud in terms of applications, visualization, or even application-specific analysis for each vertical could be pushed towards the MEC server. So this is how, a very simple scenario where IoT gateway could interoperate with the MEC platform. And from the industry side, there are several benefits that MEC's bringing into the table. For example, it's creating a whole new ecosystem. I'm not sure whether Bob would agree. He has a very different view, but a lot of people from Etsy actually think that it's going to create a whole new value chain with greater collaboration among the operators, application developers, content providers, etc. Then the very second benefit is the flexibility and rapid deployment. So for example, mobile operators, they could actually open their radio access network edge to authorized third parties, and these third parties could actually create and rapidly deploy some novel applications and services. And finally, there would be a different emergence of new markets completely addressing different aspects of MEC platform. So with that, I would conclude this part of the talk. And in my opinion, MEC and cloud will actually coexist in future. I mean, I see both of them as complementary platform where MEC could actually provide real-time platform for data analysis, and cloud could be used as central storage or some analysis that does not require real-time functionalities. So with that, thank you very much, and we can actually begin the question-answer session. So Nahom, you started saying something. You can go on.
Yeah, I'm sorry, I didn't understand.
Oh, it's fine, it's fine. Don't worry.
But we heard today a lot of time the word smart, and a friend of mine, Sanj Sirpal, says that adding sensors does not make your product smart. Trust me, I didn't get any smarter with my Fitbit, okay? So the question is, what is smart?
I can answer that.
Please do.
Please, could you please speak in the mic? Yes.
As a long-time automation and control systems type of engineer, and this dates me a little bit, 20, 30 years ago when I was doing projects for industrial clients, the budgets, as always, were tight. The cost to put instrumentation and control systems around and throughout a plant was fairly expensive. Like a Foxborough computer by itself was $1 to $2 million. So you end up only able to put out dozens, maybe 100 or 2 sensors throughout the facility. That leaves out a lot of information that could be gathered and used to manage a modern day facility. Fast forward to today, we've got a perfect storm. Low cost, in many cases solid state based sensors that are very accurate, able to output information that's characterized to what you're measuring right there at the point of capture. It hops on an internet or Ethernet cable that is non-proprietary, very fast, and then it goes to the cloud where you can process information in virtually real time, which was not true in the past. So I think smart equals the ability to gather more and better information, and then using cloud-based tools such as a Hadoop, understand what just happened, and also look for trends that might be pointing towards something that could happen next week. So all this information properly used together could equal a whole lot of smart in my mind.
Well, obviously we use anthropomorphic terminology like smart. And, you know, these words have things. I mean, I use it in a very simple sense is we use the term smart, you know, to mean a computer capability. Then what we do with our smarts is an issue.
Yeah.
And, you know, we do have all these devices and stuff. At some point, I want to avoid using the term cloud and things to just say you can do computing wherever. That if it's a factory, it makes sense to do that computing locally in the factory or wherever. And yes, the networks are better and stuff. The main change is we have generic connectivity as opposed to needing a special instrument bus and special connectivity. So devices can be adjacent no matter where they are. But at times when the physical world intrudes, you'd like the computer to be local.
Yeah. And if I could add one point, that smart also needs to be interpreted in terms of the context. For example, if you see your Fitbit, it records the number of steps you have, let's say, walked every day. But if you, take this data to a doctor, it might not be as useful as you think. Because I have actually spoken to a lot of people who take their data gathered by Fitbit to the doctors, but they are actually saying that it doesn't make any sense. So even though we think that putting a Fitbit makes this, it's a smart wearable system, but it's actually not.
Well, I think that goes to another point, the TMI problem.
Could I just relate to this Fitbit thing? And okay, there are 2 points. Okay, the Fitbit allows you to see how your physical activity distributed throughout the day, and there were some experiments that found out that people who distribute their activity throughout the day fare better than people who do it at night for 1 hour. Okay, so that's one thing. The other thing is that some companies now will reduce your healthcare cost, your healthcare fee, if you show them from Fitbit or another tracker that you're actually active. But they don't know of my experiment in the New York bus, and I say to people, if you take the Fitbit and you tape it into a vibrating device, let's say a chainsaw, by the time the battery is dead, you will be in Guinness Book of Records.
Yeah, exactly.
So.
Yeah, there's a whole separate, getting to, how to interpret the information. And there is this whole worry that we're going through the Robert Moses phase of the omniscient smarts that will look at your Fitbit, decide what your health should be, and start to build in all the stuff. But that's getting into sort of, a whole set of policy issues as you come to terms with opportunities. We have to remember the term smart also means it hurts.
Yeah, yes.
Something smarts.
Yes. Okay, any questions from the audience? Yeah.
Well, so just to be a conspiracy theorist, I think that there's also too smart. Right? It's funny, it always makes me think of the Terminator movies, right?
Yeah.
But the thing is, I always kind of say it half tongue in cheek, because, only in the last couple of years, when I go to various IEEE talks and conferences, different technologies and all that, I come to realize in the last couple of years that I actually see all the pieces for something like that as a reality. I've actually come to believe that it's not even a matter of if, but when. Something like that will happen. I don't know, the extreme example, whatever, the Matrix, or something like that. But anyways, you get the point, right? That we can't help it, right? As technologists, engineers, or just corporations, or greedy hedge fund managers, or whatever. But we're going to press forward with this stuff and keep improving these things and these different pieces, and they're all going to come together. And eventually, there's got to be some, either amazing singularity, right? I've certainly heard stuff about artificial intelligence, and I'm sure there'll be some amazing singularity, but will it be a positive one or a negative? It ought to be the greatest thing ever happened, or the end of civilization.
Well, you machine Uberlord thanks you for your interest. But remember, singularity is where everything is undefined.
Yeah. I remember Lee was giving a webinar probably middle of last year. It was about robotics, artificial intelligence, and Lee.
Oh,
Yeah, and at the end of the presentation, he actually said, if we want to prevent it, join the efforts from IEEE. You remember?
He talks to you.
I missed that.
somebody named Lee gave a talk.
What?
Somebody named Lee gave a talk.
From IEEE. Somebody
Yeah.
Lee from IEEE gave a talk.
Yes.
Who could it be? And you get 3 guesses.
We've got a variety of ways someone gives a talk. You've got the Speakers Bureau, you've got the people in your own section or chapter, Well, what is the?
I remember you were giving a talk on artificial intelligence, robotics, something related, probably like a year back.
Yeah.
You addressed the same question as he was asking about whether there would be a rise of like Terminators or something. Maybe, okay, we can come back to that later.
But do remember, we're just an infection on the earth.
They'll see it the same way.
Oh, no, they will see us that way. We're just this mold.
Okay, a follow-up question to...
But actually, a more serious answer is when an insurance company tells you to wear a device that's going to affect insurance, I get very worried because they're imposing the policies and models, and I worry about, if you don't have some bad behavior, you have no chance to learn.
Yeah, that is actually one of the issues coming up in Europe. So they have actually started looking into how connected vehicles, that domain, I mean, the insurance makers, the policy makers could actually utilize the data from your vehicle to determine if you have been doing rash driving or not, or even if you rent a
Creative,
car.
not rash.
Yeah, exactly. So it's an issue, I mean, it's being tackled in Europe already. Yes?
How many of you have Internet of Things devices at home? No, I didn't ask. No. Okay.
Yeah.
I don't have any conventional light switches left.
And how about trackers?
No trackers.
Fitness trackers? What about you there? What?
I just have a smartphone.
Okay.
Okay.
I have one. When my belly is too far out, I should be drinking less beer. That's my tracker. It's a smartphone.
Yes, when your belt reports the insurance
So
company.
maybe it should be a wearable that tells you stop drinking beer, you drank too much already.
Well, unfortunately, I wear it all the time. That's the problem.
Okay.
Okay.
My wife has it.
Yeah.
My problem with wearables is that they're consumer devices, and they're crap, and they're not.
Consumer quality.
Yeah.
Consumer
Because
quality.
yeah, they're not. Yeah, right.
We're treating them, insurance companies, us, whoever, are treating them as they're bad quality. But and that was your
Right.
I mean, you put up James on it, whatever. We're letting Fitbit do the quality assurance,
Well-
and they're not. That's not what they do. That's not their business. So there is some quality issue beyond just having all these new devices. But if we actually want to put some credence to them and want to rely on their feedback, there needs to be some quality assurance.
Well, the attitude is, on the average, it doesn't matter. Who cares about the quality of your device? On the average, it'll work. And that's a fallacy.
Well, and not just that, but it's, it's your point, we're not questioning the integrity of the data they're using. Like, for instance, like Lee, you remember, the mobile event power issue, right? A lot of people talk about all these different things they do to reduce consumption of the phone. And I've seen a government conference, all major vendors and things that talk about the tools they have that reduce power consumption. And I just stopped and said, well, let me ask one fundamental question. Do you know how that power is being measured and what's reported and if there's any degree of accuracy to it? And someone they'll easily tell you that, I ran this app and it tells me that when I do this, turn this off or use this in a different way, I use 30% less power. And, so depending on the method of the power data telemetry, right, at light loads, you could easily have a 30% error. So, they may actually, not only are they not thinking about what that number looks like, what it means or where it came from, but I mean, they're actually making decisions on it, right? They're touting, they've made an improvement, they're doing something different, and that's driving the market and their users and everything, and it may be based on complete crap, right? Just statistical error.
Shh, don't tell anybody. It's actually much worse than that. 40% of the psychology studies people checked are bogus.
Yeah, well, I mean, so he's an expert in power on my background in brain. So it's on, the brain, the home EEG things. They're not measuring brain electrical activity, almost certainly. So again, the quality assurance.
A scary example. I remember as a hack, people wanted to measure their portfolios. So I made available this thing called Black-Scholes numbers. And by 2007, it blew up the world. This is the way people did derivatives, and they used to make prediction. And turns out it was not a very good, it worked until it didn't, and that's the problem with machine learning. It works until it doesn't. A bigger problem is people's concept of software architecture. There's a whole set of literacy. People confuse communications of the network. So yeah, it's a mess, which is why I made my talk around playing with simple things and starting a learning process. And one thing to talk to Lee about is this tension between the standards-driven tradition and the ad hoc interconnectivity that I see enabled by putting intelligent, smarts, whatever term you want to use to anthropomorphize computing in local devices.
Yeah, I have another example with this not accurate. I had another watch, a Fitbit watch, and I had maybe 9,800 steps at that evening, and I was sitting and making a phone call with my right hand, and probably with my left hand I was moving, and suddenly he tells me, congratulations, you made it to 10,000. So that the question is where you put the device. So there's lots of ifs there. But then somebody told me that actually it's not so important. The thing is that it makes you exercise, and that's the important thing, not if you walk 10,000 or 8,000. But on the other hand, when we have numbers, we think that it's accurate. People usually use metrics, so they get an illusion that they're accurate, they're doing things in an accurate way. So I don't buy that notion that numbers should be just numbers, but I think there should be some guidelines to the manufacturers. And actually, we're thinking about some people to write guidelines to manufacturers on various devices. So,
we're all engineers, right? So that's
I'm not an engineer. I'm a scientist. Don't.
Yeah, we are technically trained people and whatnot, and but I mean the point is you have to I think go for the flip side, right? Is we have to put our shoes in the average consumer. Of course, we like all this standardization and accuracy, but in reality, it's just not pragmatic. Whether it's not cost effective, and frankly, it kind of goes to the consumer. Who gives a shit, right? I mean, that's really kind of the thing.
It was recorded.
Right? Perception is reality, and that's but the fact is that it doesn't matter if we know what reality is. Perception is reality, and that is the average consumer, and that's where all the dollars are going. So that's still, why fight City Hall when you just can't? You have to figure out how to work with it.
Well, I mean, on that end, if I truly have standards that Fitbit is, adhering to, and Fitbit is saying, we're measuring this and that, these devices start creeping into your labs, and I think that's scary. Now you're going to have labs using these computer devices.
Well, the nice,
You're giving credence to.
well, you have the important thing is to understand, the use. For example, a 10% difference in exercise steps might not make much of a difference. And one of the things about the sort of a claim of this big data, which actually makes sense, is that when you look at it as a whole, it's sort of these, you take that into account. In other words, when you study this, we get these numbers and this happens. The question doesn't matter whether the numbers are accurate, it's you find a correlation. And whether it's a causation is arguable, whether it's repeatable, those are interesting issues. But it might, in other words, if we give an example. Let's say that we discover that if you do 10,000 Fitbits a day, you live an extra 37 days and 5 seconds, or whatever it is. Now, that is about the number that Fitbit shows. It's not the number of steps. But if that relationship holds, then we call them Fitbit units or whatever. So I don't want to be now there are lab things where the exact steps are useful, but the big thing about the internet is we understand how to get reliable or useful results out of unreliable elements. But we have to be aware that that's what we're doing, and that these aren't numbers, and this is a problem like with Bayesian analysis. Bayesian models assume you have full information. And we're trying to composite things out of little snippets of information. And that's a positive sign of what things like Watson can do. But we have to be very wary about how far we take that, because once we take it outside certain domains, it doesn't work.
Okay, a lot of interesting discussion, and let me take it into a little bit of different side. It's about the presentation that Bob, you are doing about the API first and the local data analysis, local data processing approach. So currently in the industry, if you see the trends, there are a lot of data silos. Okay,
What?
data silos which
Yes.
not necessarily interoperate with each other. Do you see that API first approach could be a viable solution for that?
I don't know it's a solution, because you still have APIs and closed things, but I think the idea of API as a resource is something we need to appreciate, as having value. It's like, that's why I use a GPS example.
Yeah.
And, not all of them valuable as proprietary information. It's going to be interesting medical data. Do you want, you might have an API for your Fitbit that you use, but it's not necessarily used by everybody. And some data is only meaningless in other contexts. So it's not a religious thing, but I think overall, we do want to encourage open information.
Yes. Any points from? Okay. One question to Lee about smart grid. So I was in another conference last year where there was a presentation from smart grid, and the presenters were actually talking about a use case where you get an SMS from your electricity provider saying if you utilize your washing machine at this time, you may end up saving power and money. So do you think in future we'll have dynamic pricing in the smart homes when let's say smart grid is fully operational?
Well, the situation between the smart grid and the home is getting pretty complicated right now as utility managers and lawyers get involved. The smart home of today until tomorrow is not only able to better manage the consumption of energy, and there's an argument that says, hey, if I do my part to save energy, you should give me a break on the cost of energy. But the homes are generating energy, and in some cases, a surplus of energy, and the homeowner would like to sell it back to the grid. So all these things are being debated heavily right now, and the relationships and the protocols and the legal aspects of how do you do that is constantly not only being discussed, but we're moving towards this net neutrality way of handling electricity. For example, utilities would like to charge a homeowner with solar panels a chunk of money every year, whether they pay or deliver energy back in the grid or not, because they've got to pay for the wire and the infrastructure to get to that home. And the homeowner doesn't understand that. But the utility has to maintain those assets, and they're regulated to make sure they not only have to have a high reliability grid, but the grid must go everywhere within their area, even if your home is 10 miles back into the woods. So there's no simple answer right now, but the technology is there to make it all work together. And the answer is the lawyers and the managers and the consumers have got to come to a consensus of who should pay what fair share for all of this to work together.
Okay, actually, some quick points. First, it would be nice if people took accounting, because when you talk about fair share, you're talking about what accounting model to apply, and whether you should have things like opt-out of the grid or something, and people need to understand the decision metrics, so that's important. The other thing is, when you say SMS to the home, this is where APIs are a great example. And because I remember when I first learned about this demand-side power management 20 years ago, the idea was the power company would shut off your machines directly. But if there's an API, we're starting to have a way to have the dynamic negotiation in a way that can actually work. Because in the home, you decide your policies, and there might be a market for policies. But, so I think a lot of this, well, the net neutrality also has some of the similar problems, which is why I think it's misframed. But the example in the grid is, it's like a restaurant. You pay for the food, they charge you for the food, what you're really paying for is the rent of the space. So, the question is, can we have rational, explanation that this is you're paying for the physical infrastructure separate from the power, instead of an accounting practice which tries to put it all into one number. Oh, also, Brian is, is a power manager, speaking about the whole DC power thing, flow of power, which is very interesting.
Actually, when we talk about the smart grid stuff, and I will be talking about this in more detail tomorrow, but I think it presents some opportunities to really kind of almost flip the whole utility grid model upside down, and in a way with dynamic pricing and too much, so much optimization intelligence, I'm almost afraid that there's a potential for it to turn into just like what high-speed trading does to the stock market, right? And like for instance, electric vehicles, right? If everyone has an electric vehicle, we say, okay, now we know prices are basically high during the day, low at night. So it says you're going to want to plug it in the night. You want to use reduce your consumption during the day and the night. Well, if everyone had an electric vehicle and everyone plugged in their EV when they got home from work, that would flip the model completely. You'd be blowing your transformers on the street, and it would just completely flip the model. So now imagine if everything in your home is is monitored, is plugged into this, is intelligent. What happens when everything's trying to optimize the model, and it exceeds the ability of the human to do that? Well, it's uncharted territory.
Yeah.
Well, it's also the Moses problem. You're starting to build in all the assumptions about the way things are today.
We're at 10 minutes.
Okay.
Oh, you're right. They booked it back like that.
Yeah. Well, the good news is you don't have to go into the gondola until 7 o'clock.
No,
The drink is at 6 to 7.
six.
No, I spoke to Stu. Drinks at 6 to 7. Right is at 7. What?
The drink's the most important part.
No, I'm saying you can get the reception, but if you're 5 minutes late, it's not like missing they close the door in the gondola. But I think we are done.
So, yeah, exactly. So with that, I would like to conclude the session. Thank you very much for staying back, and thanks a lot to the panelists for your views and the presentations.
And remember, when you're on the monorail, you're riding the future as of 1950.